Today we're starting our new unit on polynomials. So today we're going to review vocabulary related to polynomials and learn about synthetic division. By the end of this video, you should be able to factor and find the roots of a polynomial using synthetic division. So first of all, what is a polynomial? Well, a polynomial is a function of this form here, which I know doesn't really clarify anything. So one example of a polynomial is a quadratic. You have positive integers as your exponents, and then you have coefficients of each of those terms. So a quadratic is a type of polynomial, a linear function is also a type of polynomial, and we'll talk about a couple other types of polynomials in a minute. But the key thing to remember is that there are no weird things going on in the function. There are no square roots, there are no absolute values, there are no negative exponents, there are no variables in the denominator. It's just a nice, normal looking equation. Standard form of a polynomial is when it's written in decreasing exponent order. So for example, when we talked about quadratics, standard form meant that the squared term was first, the x term or the linear term was second, and then the constant was last. So you always want the term with the highest exponent to go first, and then to continue on in decreasing order, and the constant to be last. The degree or order is another word for degree, is the highest exponent. So for example, when we talked about quadratics, the highest exponent in all of those equations was a 2. There was an x squared term, so that is considered a second degree polynomial. The leading term is the first term when the polynomial is written in standard form. So after you've written it in standard form, whatever term is in front is your leading term. The leading coefficient is the coefficient of the leading term. So for example, if we have a quadratic that starts out with 2x squared is the leading term, and 2, the coefficient of that term, is your leading coefficient. So let's look at some common polynomials. A constant function is one that's just a constant term, like f of x equals 3. This is just a horizontal line. Since that has no x's in the equation, that is a 0 degree polynomial. A first degree polynomial is also known as a linear function. So that's like what you spent most of your time working on in Algebra 1, something like 2x minus 1. Now we have a familiar example here in the third line. This is a quadratic. We said that the degree is the highest exponent. You'll notice that the highest exponent is a 2. So it is a second degree polynomial. The next one is a third degree polynomial because our highest exponent is a 3. And this is called a cubic. We've looked at these a little bit when we did factoring and a little bit when we did our parent functions. The last one is a quartic, and this is a fourth degree polynomial. Make sure that you don't confuse the words quartic and quadratic. So fourth degree polynomial will definitely have x to the fourth, but it might not have all the other terms. It can skip some terms. That's okay. So a polynomial does not have to have every term. As you go down in exponent order, it can skip some terms. That's fine. So these are the most common polynomials. There are, of course, higher degree polynomials that also have names, but we're not going to be working with those too much. So the next thing we need to do is see if we can figure out if something is a polynomial or not. If it is, then we're going to write it in standard form, say the leading term, degree, and leading coefficient. So the first problem here, we have 8a to the fourth plus 4a cubed plus 17a squared. So even though it has a's and not x's, this is still going to be a polynomial. There are no weird things going on. There are no negative exponents. There are no variables in denominators. There are no square roots, no absolute value. It's just a normal looking equation. So standard form means that exponents are in decreasing order. So if we look at our exponents, we have 4, then 3, then 2. So this is already written in standard form. Now our leading term is going to be the first term now that it's written in standard form, which is 8a to the fourth. The degree is the highest exponent, so it'll be 4. So this is a quartic. And the leading coefficient is the coefficient of the leading term, which is 8. Let's take a look at the next example. We have 5y to the negative fourth plus 7. This is not a polynomial because there is a negative exponent. So that means we can't answer any of these other questions because this is not a polynomial. Problem number 3 here, we have 9x cubed minus 2 minus 3x cubed. So this is a polynomial. Again, there are no negative exponents, there are no exponents in the denominator. It's just a normal looking equation. But this is not in standard form. If we look at our exponents, we have an x cubed and we have an x squared. So the x cubed term needs to come first. Then the squared term, and make sure that you know that the subtraction symbol will stay with that term. And then the constant should always be at the end. Now the leading term, now that it's in standard form, the first term is our leading term. The degree is the highest exponent, which is 3. So this is a cubic. And then the leading coefficient is the coefficient of the leading term, which is 9. All right, so let's continue. Now, before I talk about synthetic division and polynomial division, let's go back to like 4th grade and review long division. So if we want to take 4,086 and divide by 19, first thing we want to do is look at the number 19 and see how many times it goes into 4. Well, 19 doesn't go into 4 because 19 is a lot bigger than 4. So then we'll look at the first 2 numbers. So how many times does 19 go into 40? The answer is 2 times. So I'm going to write a 2 over the 0. Then I'm going to multiply 2 times 19 and write it below the 40. Then I need to subtract 40 minus 38, which gives me 2. Then I'm going to bring down the next digit, which is an 8. So now I have 28. I want to see how many times 19 goes into 28. That's 1 time. Then I'm going to multiply 1 times 19 and write it below the 28. Then you subtract 28 minus 19, which gives you 9. Then I'm going to bring down the next digit, which is a 6, and get 96. Then I want to see how many times does 19 go into 96. The answer is 5. So then I need to do 5 times 19, which is 95. Then subtract, and I get 1. Now, there are no more digits for me to bring down. So then I'm going to write this remainder as a fraction. So if I have 1 left over, that means I have 1/19 extra. So my final answer is going to be 215 and 1/19. So this is just a reminder of how to do long division because we're going to use it in a moment with polynomials. So I'm going to show you how to do polynomial long division, and then I'm going to show you a different way to do division that is typically easier. But the other method, synthetic division, does not always work. For right now, you'll always be able to use synthetic division, but just know that sometimes you do have to do long division with polynomials. So I just want to show you how you do that. So when you do polynomial long division, you only look at the leading term when you're trying to divide. So my leading term here is x squared, and it's x over there. So I have x squared plus 3x plus 7, and I'm dividing that by x plus 1. So I want to see, what is x squared divided by x? Well, that's just x. So I'm going to write that above the division line. Then, just like with regular long division, I need to multiply x times x plus 1. Remember, you have to distribute. So that gives me x squared plus x. Then I'm going to subtract. So I have x squared minus x squared, which cancels out. Then I have 3x minus x, which gives me 2x. Then I'm going to bring down the next term. Then again, I'm going to just look at the leading terms. So I have a 2x here, and then x over here. So what is 2x divided by x? Well, that's just 2. So I'm going to write plus 2. Then I need to multiply. So I'm going to do 2 times x plus 1. Remember to distribute. So I get 2x plus 2. Then I need to subtract. So 2x minus 2x cancels out. And 7 minus 2 gives me 5. So now I don't have any other terms to bring down, so now I just need to write the rest of my answer. So I had 5 left over, and I was dividing by x plus 1. So my final answer here is x plus 2 plus 5 over x plus 1, which doesn't look like it would be helpful because it looks more complicated than the original problem. But this is just an example of how to do long division, and I'm going to show you how synthetic division works. So, when you do synthetic division, this only works if you are dividing by a linear term. So we're dividing by x plus 1. That's a linear polynomial. So this will work. So when I do my synthetic division, I'm doing x squared plus 3x plus 7 divided by x plus 1. So I'm going to start off with the coefficients from that quadratic, x squared plus 3x plus 7, which the coefficients are just 1, 3, and 7. And I'm going to draw this L here. Then I'm dividing by x plus 1. So I'm going to do a little bit of work off to the side just to show you where I'm getting this. If you take x plus 1 equals 0 and you solve it, you get x equals 1, or x equals negative 1. So I'm going to use a negative 1 for my synthetic division. So I'm going to write that outside the L. So if you had 2x plus 1 as your thing that you were dividing by, you would end up with x equals negative 1/2, so you would use negative 1/2 on the outside. So when you do synthetic division, the first thing you do is just bring that first number all the way down. Then, whatever number you have here, you're going to multiply by the number outside the L. So negative 1 times 1 is negative 1. And I'm going to write that answer under the next column. So what I did was negative 1 times 1, and I wrote my answer over here. Then I'm going to add 3 plus negative 1, and that gives me 2. Then I'm going to multiply, so I'm going to do negative 1 times 2, which is negative 2, and write that in the next column. Then I'm going to add 7 plus negative 2, and that gives me 5. And I'm going to use those numbers at the bottom there to write my answer. So this last digit is always your remainder. And if you look here, that was the remainder that we had when we did long division. Then I have a 1 and a 2, which are the same numbers that I had here. These are the same coefficients from this answer when I did long division. So when you write your answer from synthetic division, your answer is always going to be 1 degree lower. So I started with a quadratic. So 1 degree less than that is a linear function. So my answer is going to be a linear function, and these are my coefficients. So my final answer here is 1x, or just x, plus 2. And then this is my remainder. So plus 5 over x plus 1, which is the same answer I got when I did synthetic division. Now, why is all of this helpful? Well, let's take a look at a couple theorems. Well, an expression that divides exactly into another expression is called a factor. That's the same terminology that you used in elementary school when you talked about factors. An expression that divides exactly into another one is a factor. 3 goes exactly into 12, so 3 is a factor of 12. It's the same idea when we talk about polynomials as well. So, the factor theorem says that a polynomial has a factor, x minus k, if and only if f of k equals 0, or the remainder equals 0. So, just to review, because this is an important concept, if x minus k is a factor of an equation, then x equals k is the root or 0 or solution to the equation. So the important thing to remember here is if you are given a factor or a root or a solution to an equation, you can use that and synthetic division to find all of the other roots. So let's take a look at one example of this. I want to use synthetic division to determine if x plus 2 is a factor of this polynomial here. F of x equals 3x cubed minus 4x squared minus 28x minus 16. So I'm going to set up my synthetic division. I'm going to start by writing out all my coefficients. So I have 3, negative 4. Make sure you pay attention to the negative signs. Those are going to be important. I'm going to draw my L. Then, since x plus 2 is the factor I'm looking at, negative 2 is going to be the number I write out front. Then I'm just going to follow my pattern for synthetic division, and if I end up with a remainder of 0, then x plus 2 is a factor. So I'm going to start by bringing down the 3. Then I'm going to multiply. Negative 2 times 3 is negative 6. Negative 4 plus negative 6 is negative 10. Then I'm going to multiply. Negative 2 times negative 10 is positive 20. Then I'm going to add. Negative 28 plus 20 gives me negative 8. Then negative 2 times negative 8 is positive 16. Then add. Negative 16 plus 16 gives me 0. So I got a remainder of 0. So x plus 2 is a factor. So now I'm going to continue. Since I know that x plus 2 is a factor, I want to finish factoring this cubic. So I've already done my division. I started with a cubic, so my answer will be 1 degree lower, which is a quadratic. So these numbers here, the 3, the negative 10, and the negative 8, are the coefficients for my quadratic. So that gives me 3x squared minus 10x minus 8. And I just need to finish factoring that. So if you need to do factoring by grouping, that's fine. If you want to use the box method, that's also fine. If you've gotten comfortable with factoring and you can just kind of do trial and error, you can almost see the factors immediately, then that's great. I know that the only factors of 3 are 3 and 1. So I know that one of my factors is going to start with a 3x and the other one is going to start with an x. So then I need numbers that multiply to negative 8 and make sure that when I multiply it out and double distribute that I end up with a negative 10 in the middle. So I'm going to try 2 and 4. Since these need to multiply to negative 8, one needs to be positive, one needs to be negative, and I need to add up to negative 10 in the middle when I multiply. So if I make this a negative 4 and this a positive 2, when I double distribute it out, I'd end up with 3x times negative 4, which is negative 12x, plus 2x, which is negative 10x. But when you're writing out the factors, don't forget the factor you already figured out, which is x plus 2. So these are the three factors of this cubic. The last question says find the roots. Remember that roots, zero solutions, and x-intercepts are all the same thing. So all I need to do is set all of these equal to 0 and solve them. So I end up with x equals negative 2, x equals negative 2/3, and x equals 4 as my roots. Now, there is one thing you have to be careful of. With synthetic division, if you have a term that is missing from your polynomial, for example, if you have x cubed minus x plus 1, we're missing the x squared term. So when you set up your synthetic division, you have to make sure you put in a 0 to represent that missing term. So when I set up my synthetic division, my first coefficient is 1. Then I'm missing the x squared term. Then my next coefficient is negative 1, and my last coefficient is 1. So make sure you put in that 0 whenever there's a missing term. So when there's a term missing from the polynomial, you have to put a 0 in the synthetic division. So take some time to practice synthetic division. Once you get the hang of it, it's not too hard.